thing now. It's recording, I think. Yeah, it is. Yeah, it is. Okay, great. Awesome. So we'll continue our discussion on L'Hopital's rule, and we will introduce more indeterminate forms. Thus far, how many indeterminate forms have we seen? Do you remember them? 4. Yeah, so what are they? Very good. Who can help me? Who wants to help? Yes? Infinity minus infinity. Someone else for another indeterminate form? Yes? 0 over 0. 0 over 0. Yeah? Infinity times 0. And there is one. Yes? Infinity over infinity. So these are the 4 indeterminate forms that we have seen. And we have seen a way L'Hopital's rule can help us deal with 2 of these forms. What are they? Directly. What are the 2 forms required to apply L'Hopital's rule? Someone else? Someone else? Someone who hasn't spoken today? Yes? Infinity minus. Well, directly. I'm saying directly. Oh, infinity over. And the other one is? Who can help with the other one? Yes? So when I have 0 over 0, thank you, 0 over 0 or infinity over infinity, I can apply L'Hopital's rule, derivative of the top over derivative of the bottom, and evaluate this limit. And that can be done as many times as you wish, as long as the form is 0 over 0, okay? And we have seen that L'Hopital is not always the best thing to try immediately. We could always simplify first and then apply L'Hopital. Great. Now we have seen 2 forms, 0 infinity and infinity minus infinity. Does L'Hopital's rule allow us to treat them immediately, or should we do something else? Infinity times 0. If we want to try L'Hopital's rule? I mean, if we cannot evaluate it directly or easily, L'Hopital's rule, what should we do before? Transform it into a quotient, infinity over infinity, or 0 over 0, and then apply L'Hopital's rule. One way is sometimes easier than the other, right? As we have seen. And infinity minus infinity, you can do 2 things. In general, I'm not saying these are the only ways to do it, but the most common ways, take out the highest term and, see what happens, right? You remember this? We did this with e to the x minus x. And then what else did we do? We rearrange the difference as a fraction and hope that we get 0 over 0, and that's it. Great. Now, we'll introduce more indeterminate forms. So what are they? Indeterminate powers. So let's see. Wait, sometimes so it's 0 to the 0. Infinity to the 0 and 1 to the infinity. So what does this mean? This means I have a power. It's a limit of the form x going to a of f of x to the g of x. Let's call this 1, 2, 3, where for 1, the limit as x goes to a of f of x is 0 while remaining positive. Okay, I don't think you'd have to worry about this part. We'll make sure that f of x goes to 0 while remaining positive, and is equal to 0 to the limit as x goes to a of f of x is plus infinity, and the limit as x goes to a of g of x is equal to 0. 3 is the limit as x goes to a of f of x is 1, and the limit as x goes to a of g of x is plus or minus infinity. Okay? These are the indeterminate powers. Now, where did these come from? Are these like out of nowhere? Let's try to look. Yes?
Why is 1 to the power of infinity not 1?
Pardon me? Oh, we'll see. Okay? We'll see. Okay? Why are these indeterminate forms? Are these out of nowhere really, or there is a reason? At first they came out of nowhere, But let me write y as f of x to the g of x. Okay? Let me write this. And what's a good thing to try here? To get rid of the power, I can introduce a ln. So ln of y is g of x ln of f of x. You guys see this? Now, what's the limit as x goes to a of ln of y in that case? In this case. So, what do you have? You have 0 times ln of 0 plus. What is that? What? Let me write this up. The limit as x goes to a of ln of y. What is the form here? So, I have g of x goes to, and case number 1, g of x goes to 0. Ln of f of x goes to ln of 0 plus, which is minus infinity. You agree? Everybody. So I have an indeterminate form. The ln of y is 0 times infinity. Let's look at the second one. Ln of y. What is the form of ln of y? Can anyone help? Where does g of x go? G of x goes to 0. Where does f of x go? To infinity. Ln of infinity is infinity. So also in the second case, the ln of that expression has the form 0 times infinity. And let's look at the third case. Ln of y is g of x ln of f of x. So if f of x goes to 1, ln of f of x goes to, everybody, good morning, ln of f of x goes to 0. So I have infinity times ln of 1, which is infinity times 0. So the ln of an indeterminate power of this form is what? Is of the form 0 times infinity. Okay? Great. Now, did we learn how to solve limits of the form 0 times infinity or not? Do we know how to do this? Great. Now, suppose I know the limit of ln y. Say the limit of ln y is 2. Can I find the limit of y? Ln y goes to 2. So, where does y go to? What's the relation between ln y and y? If I write y is equal to what? To e to the ln y. Everybody agrees. Now, if ln y goes to 2, where will y go to? E of 2. Do we agree or not? I can exponentiate both sides. Yes or no? Are we good? Great, because the exponential function is continuous. So, if the limit as x goes to a of ln of y is L, then the limit as x approaches a of y is E of L. We agree with this statement or not? This has nothing to do with indeterminate forms. This is things we have seen before. Are we good? Any questions about this? Any questions about this? Please don't hesitate to ask. Oh, yes.
For number 2, why does that plus equal?
Why? Number 2. Okay, so whenever you take a power to the something, whenever you take, like this, you want to define a to the x, okay? A must be positive. Okay? See that? Think of it like if you want to take a real, say you want to take a number to the power 1/2. This number cannot be negative. Okay? For integers, of course, you can allow this to be negative, right? Yeah. If you have integer powers. Yes?
Wait, for 1, the limit as ln y, limit as x goes to a of ln y, wouldn't f of x go to minus infinity?
Yeah. g of x would go to 0, and ln of f of x would go to minus infinity. Yeah. Oh, you mean the sign here?
Yeah.
Yeah, sure. I mean, this is just the form. When the form, I drop the signs. Okay? This is not a number, right? This is... Okay? This is not a number. Okay? But you see the form is 0 times an infinite. Is that good? Yeah. Okay, great. Let's continue. So if I want to solve a limit of this form, yes.
So if you don't have a
Yes, 0 times infinity is indeterminate. Yep. Okay? So if I want to solve a limit of this form, if I figure out the ln, I can do it. Right? Let's try it by an example. So the idea, well, let me do this here. Let me write this here. Idea. If you want to find the limit as x goes to a of f of x to the g of x, set y is equal f of x to the g of x, then ln y is equal g of x to ln f of x. Of course, f of x must be strictly positive here. Fine. Any questions? No? Then find the limit as x goes to a of ln y, then the limit as x goes to a of f of x to the g of x is equal to the limit as x goes to a of y e to the limit. Okay, are we good here? Is that clear or not? Is that clear? Guys, is that clear? Let's give an example. So let's start with 0 to the 0. The limit as x goes to 0 plus of x to the x. First, is this an indeterminate form? Whether it's an indeterminate form or not, just let's try to introduce the ln to make things easier. Okay? Great. So the form is, I mean, I always write it. It's better to do it. So it's 0 to the 0. What should I do? Let's look at this recipe. Well, you can apply it or you may not apply it. That's fine. It's up to you. What should I set? How should I start? I set y is equal to what? To x to the x. Let y okay? What's the next step? What do I take? Ln y. Ln y is equal to what? Is x ln x. We agree with this or not? Should I write the step or that's fine? That's fine? Yeah. Okay, what do I need to find? I need to find the limit as x goes to 0 plus of ln y. This is the limit as x goes to 0 plus of x ln x. So far so good? Okay, what do I have to do here? X ln x. Well, let me write here. I try to plug in. I'll just write it here. What is the form of this limit? Plug in, plug in, try to plug in. What is this form? 0 times infinity, right? Because ln x will go to minus infinity and x will go to 0. Great. Now, how can I solve this? Can I immediately apply L'Hopital's or I should transform? I should do a transformation. I should do a transformation. What do you suggest doing? Someone else? No? Okay. Yeah? Exactly. So maybe I can write this as the limit as x goes to 0 plus of ln x over 1 over x. So far so good. Let me plug in. Ln x goes to minus infinity. 1 over x goes to plus infinity as x goes to 0 plus. So I do have an infinity over infinity. What can I apply now? I apply L'Hopital's rule. Derivative of 1 over x. What's the derivative of 1 over x? What's the derivative of ln x? 1 over x. What's the derivative of 1 over x? It's minus 1 over x squared. Now, what's better, applying L'Hopital's rule here or simplifying first? Let's simplify first. I get it's the limit as x goes to 0 plus of x squared, of minus x, which is 0. I'll erase here. Okay, is that fine? Yeah. Great. Now, the limit of ln y as x goes to 0 plus is equal to what? Is equal to 0. What's the limit of y? So the limit as x goes to 0 plus of y is equal to the limit as x goes to 0 plus of e to the ln y, which is e to the limit as x goes to 0 plus of ln y, which is e to the 0, which is 1. So the limit as x goes to 0 plus of x to the x is 1. Are we good here? Are we good? Yes?
For the previous example, you have ln x over 1 over x being, as it approaches 0 plus being infinity over infinity.
Exactly.
If you plug in 0 for the denominator, wouldn't you get 0?
What? Yeah, exactly. That's it. You treat the denominator on its own.
Yeah.
Okay? 1 over 0 plus is infinity. Okay?
Yeah.
And then please pay attention to something. You don't differentiate the entire quotient. You differentiate the numerator and you differentiate the denominator. Okay? Don't differentiate the entire thing. Differentiate the numerator alone and the denominator alone. Any questions? Are we good here? Should we do one more example? Let's do one more example. Now I don't know what I should erase actually. Did you all copy this down or not? Did we copy this down? Because I prefer to keep this. I prefer to keep these things. Okay, so we've had this thing. So find the limit as x goes to plus infinity of x to the 1 over x. I mean, I don't think it's going to be that different, but I'll change the numbers later. I mean, I think we'll get the same answer. We'll get 1, but next time I'll give you an answer, a number that is different. Great. Let's try this. Or you know what? Let's why do we have to do it with 1? So 1 plus 2x to the 1 over x. Okay, won't change that much, but you know. Great. Now let me, first of all, what do? I plug in. 1 plus 2x goes to, everybody, plus infinity. 1 over x goes to 0. So I have an infinity to the 0. Okay, this is infinity to the 0. Now, what can I do here? What should I do? Let's look at the board on the right-hand side, on your right hand. What should I do? I set y equal to 1 plus 2x to the 1 over x. Oh, wait a minute. I don't think it will change a lot. Oh, maybe. I don't know. Let's see. No, I think it may. Anyways, let's see. I don't know. But, so I have y is equal to 1 plus 2x over 1 over x to the 1 over x. What's the next step? Please look at the next step. What is it? Who volunteers? No one? Yes?
Take the log of both sides.
Take the ln of both sides. So ln of y is equal 1 over x times ln of 1 plus 2x. Okay, then what's the step after? I take the limit as x goes to 0, as x goes to infinity. Of what? Of ln y okay, let me rearrange that in a very nice way. Over x. Now, let me plug in what happens here. What happens? Infinity over infinity. Right, I just put the x down. Otherwise you're right, right? It's 0 times infinity. I just put the x down. You get infinity over infinity. Great. What can I apply? I apply L'Hopital's rule. Yeah, if I had a square here, I think it would have been good. But anyways, let's not change it. 2 derivative of top. 2 over 1 plus 2x over 1. What's this limit? Oh, not even. No. Even if I had a square. I don't know. Anyways. What is this limit? 2 over 1 plus 2x over 1 as x goes to infinity. What is this? 0. The limit of ln of y as x goes to infinity is 0. What is the limit of y? Why is that? So the limit as x goes to infinity of ln of y is 0. Okay? Is that clear, everyone? Questions or no? Yes?
Will we ever see a case where you have like, one constant term and then another term to the power of x? Not both of them raised to 1 over x, just one, and the other one just.
So you figure out the power, then you multiply with the constants.
But what if it's not in the bracket?
So if you have 3 times x to the 1 over x.
So I have 3 plus x to the 1.
That's what you just did.
But the 1 is outside of the bracket.
So you said 3 plus x. Is that it? Yeah. This one will go to 1 plus 3, 4. Okay? Great. Questions or no? Are we good? It's good. Please, if you have questions, please ask me in the back. Yeah. Are you good? Yeah. So far so good. The front, fine. In the back, are we all good? Great. Let's do one more example. Let's see. Let me try. Okay, let's try to. Okay, I mean I did. Can I erase here? I'll erase here and just try to do one that I think I looked at is from your book, and then finish this L'Hopital's business. It's the limit as x goes to 0 plus of 1 plus sine 3x to I don't know why I touched it. 1 plus sine 3x to the power cotan x. Cotan. Okay? 1 plus sine. Oh man. I think it was fine before. What did I do to mess it up? It's the limit. As x goes to 0 plus, what did I have? 1 plus sine 3x to the power cotan x. Okay. Plug in. We plug in. 1 plus sine 3x goes to, everybody? Sine 3x goes to 0. 1 plus sine 3x goes to 1. Cotan x as x goes to 0 goes to plus infinity. You see this or not? So cotan x is cosine over sine. Agree or not? Sine as x goes to 0 plus approaches 0 while remaining positive. And cosine goes to 1. So you have 1 over 0 plus. What is cotan x going to? It's infinity. You have 1 to the infinity. So far so good or not? Everyone, any questions on this? Great. So what's the next step? Who can help me with the next step? Look at the board on the right hand side, please, on your right hand side. What's the next step? Yeah? Set y equals something. Very good. At the same time, can you give me the next step? Take the ln of y, thank you. So ln of y is equal to cotan x ln of 1 plus sine 3x. I didn't put the brackets, that's fine. And then what do I have to do? I have to find the limit as x goes to 0 plus of ln y cotan x times ln. Okay. Now, let me plug in. I get a form of infinity times 0, right? Well, whatever. Yeah, infinity times 0. You guys see this? 1 to the infinity. If I take the ln, I get infinity times 0. You see that? Yeah? Is that what I get here? Cotan goes to infinity, ln of 1 is 0. So it's infinity times 0. What do I have to do here? Can I apply L'Hopital's? Can I apply L'Hopital's to evaluate this thing? Or should we do something else before? Yes, sir.
How come it's not ln of 2?
Ln of
It's 1 plus.
sine 3x.
Yeah.
Sine 3x goes to 0.
Oh, right.
So ln of 1. Okay? Are we good? So, yes.
You can make it ln of 1 plus sine 3x over 1 tangent x.
Very good. So let's do this. Or, I mean, I'll that's one way. But, sure. Let's do it your way. I mean, who likes working with cotan? Who likes working with cotan? So 1 over cotan, what is that equal to? 10. Okay? So I have 1 over cotan. Very good. Now let's transform this 1 over cotan to 10. That's nice. Great. I transform it into a quotient. Before I apply anything, what do I have to do? I have to plug in. So what do I get? What's the form of that? On top I have ln of 1, right? And on the bottom I have tan of 0. What is ln of 1? 0. What is tan of 0? 0. So what do I have here? I have a 0 over 0. So what can I do? I can apply L'Hopital's rule. Can I erase the right hand side? Is that good? I think we won't need it anymore because this is the last example. I mean, I don't know why I kept the above one. I don't know why, but I think it's good to. Great. Now, what do I have to do? I apply L'Hopital's rule. Who wants to help me differentiate? Who wants to help me differentiate? Who wants to help differentiate? Yes?
3x over 1 plus sine 3x over 36 squared.
Yeah? Is that okay? You had 1 over cosec squared, you said? Or you had C? You said 1 over cosec squared? That's fine. Yeah. Okay. You differentiated tan as sine over cos. Okay. That's good. That's good. Great. Now, can I evaluate this limit easily or not? So let's look at the top. 3 cos times 3 cos of 0. Let's plug in. What do you get? 3. 1 plus sine of 0, 1. Over secant squared of 0 is 1. So what do you get? The final answer is 3. Okay, so the limit of ln y is equal to 3. Hence, the limit as x goes to 0 plus of y is equal to the limit as x goes to 0 plus of e the ln y ln y is equal to e of 3. Hence, conclude that the limit, oh well. Are we good here? Is that clear? Hence, are we good here? Is that clear? Everybody, is that clear? Okay, so I suggested some questions from the book. I tried to stay away from the book examples. I think this one is from the book, but it's solved. It's a solved question. So you guys can do the book. And this is an answer to your question. 1 to the infinity gave you e of 3, right? It's not necessarily 1. Okay, are we good here? Is that clear? So if you have an f of x to the power g of x, how do we solve this? I set y is equal f of x to the g of x. Ln y is equal g of x ln of f of x. I find the limit of ln y, and I don't forget the last step is to exponentiate my answer. Is that good? Yes. Okay, great. Now we'll move on to a new chapter. Is critical numbers. So L'Hopital's is done. Okay. Now here we're going to look at critical numbers of a function. And the closed interval Okay? So critical numbers of a function and the closed interval method. I mean, at the end of this chapter, the goal is to find the max and min of a continuous function on a closed and bounded interval AB. So the remaining of this lecture, of course we'll not get to the last part, is just to define the notions that we will need. Okay, this is the goal. So let's start with the definition. I don't know how. Yeah, okay. A critical number of a function f is a number in the domain of f. This is very important. Where is a number c, let's say, in the domain of f such that f prime of c is equal to 0 or f prime of c does not exist. So basically, if I look for the critical numbers of a function, I'm looking for points in the domain of the function where the derivative is 0 or the derivative does not exist. Okay? Examples, let's start with some examples. Zero is a critical number of the absolute value function. Why is that? Is f differentiable at 0? But is f, first of all, is f defined at 0? Is the absolute value function defined at 0? Everybody. Can I take absolute value of 0? Yeah. Is f differentiable at 0? No. So 0 is a critical number of f of x is equal absolute value of x, since f is defined as 0, but not differentiable at 0. Now, is 0 a critical number of f of x equal 1 over x, or that doesn't make sense? Let's look at a definition. Saying that 0 is a critical number, does it make sense or not? Of f of x equal 1 over x. What's the first thing to check? That 0 is in the domain. Is 0 in the domain of f of x equal 1 over x? 1 over x, can you define 1 over 0? No. So is 0 a critical number of f of x equal 1 over x? No. So 0 is not a critical number of g of x, let's say, equal 1 over x, since g is not defined as 0. Now, a critical of a function, oh my god, I forgot. A critical number or value, okay? Some use value, some use number. I think the book uses number. Great. Now, let's do some examples. I've written them down. Find the critical numbers of each of the following functions. So I have 1. What is the first function I have? It's f of x equal x cubed minus 3x squared plus 1. Of course, if you're going to practice this, even go for page book. Page, oh well, yeah, I'll do it later. Take off those, that's fine. Okay, now let's look, first of all, I need to look for critical numbers. So first of all, I need to find the domain of f. What is the domain of f? F, all real numbers. Why is that? F is a polynomial. Great. Now, a polynomial, where is it differentiable? It's also differentiable on the whole real line, right? So, f is defined and differentiable on R since f of x is a polynomial. What is f prime of x? So this tells me, do I need to worry at points where the derivative is not defined? No, because the derivative is defined everywhere. What's f prime of x? F prime of x is 3x squared minus 6x. And I have to solve this equal to 0. So I better have it factored, right? So it's 3x times x minus 2. Now what are the critical values? Critical numbers. What are the numbers that make f prime of x equal to 0? 0 and 2. That's it. Okay? Easy so far, right? Are we good here? Is it clear? I'm looking for points where derivative points in the domain where the derivative is 0 or the derivative does not exist. Where's the derivative 0? 0, 2. Okay, let's do another one. Two h of x is equal to x squared minus 1. Well, x squared plus 1 over x squared minus 1. This is a rational function. You agree? Where is it defined? It's defined wherever the denominator is non-zero. So the domain is, have you seen the minus notation or that set minus? Have you seen this before? R minus plus minus 1. Have you seen this or not? Yeah, if you haven't seen this, this means that this is, well, what's the domain? Minus infinity. Minus 1, union minus 1, 1, union 1, infinity. Basically, all real numbers that are different than 1 and minus 1. Okay? That's the domain. Now, is h differentiable at every point on its domain or not? A rational function is differentiable at every point in its domain, right? We have seen this, and what is h prime of x? H is differentiable on its domain. I mean, I don't like this. I'd like to say on every open interval of its domain, but that's fine. We'll take this. And what is h prime of x? What do I use? Quotient rule. It's 2x times x squared minus 1 minus 2x times x squared plus 1. What is that? So what do we get? What do we get? So do we get minus 4x over x squared plus 1, x squared minus 1 squared? Did anyone try it or not? I mean, let's just do it. It's 2x times x squared minus 1 minus 2x times x squared plus 1 over x squared minus 1 squared. So what do you get? You get minus 4x Now, do I have to worry at points in the domain where h prime doesn't exist, or h prime exists at every point in the domain? Is there any point in the domain where h prime doesn't exist? H is differentiable in its domain. So really the critical values here are values that make the derivative equal to 0. Now, are 1 and minus 1 valid for critical values or not? 1 and minus 1, are they valid for critical values? Let's read the definition. A critical number value is a number C in the domain of F, or 1 and minus 1 in the domain of H. So are they valid as critical values? Everybody? No. Okay? So really, what is the only critical value here? 0. If you want to solve this equal to 0, critical number. Okay? Now let's do another one. G of t is t minus 5 t to the 1. Can you read this? Yeah, it can be read easily. Yeah. Okay. What is the domain of G in this case? Please raise your hands. What is the domain of G? Yes, sir.
It's defined everywhere.
It's defined everywhere. You guys see this? There's no problem in plugging in any number. You guys see this or not? Yes. G is defined on R. Great. Now, where is G different? What is the derivative of G? Where is G differentiable? Do you have an issue differentiating T? The first term, do you have an issue differentiating it? Everywhere. So G prime of T, what is that? This is 1 minus T to the minus 4 over 5. 4? What's the condition here? What's the condition? Is G differentiable everywhere? No. For T different than 0, right? You have a negative power. You see that? Can you plug in 0 here? No. So G is not differentiable at 0. I mean, you can check that. This doesn't prove it, but you can check by the limit definition that G is not differentiable at 0. So, do I have a critical number automatically? Do I get a critical number here? Do I have a point in the domain of G where G is not differentiable? Yeah, so 0 automatically is a critical number. Well, is it the only critical number? What do I have to solve? I also have to find the numbers where the derivative is 0. So let's solve that. G prime of t is equal to 0 is equivalent to t to the minus 4 over 5 is equal to 1. Now let me raise both sides to the power 5. So t to the minus 4 over 5 to the power 5 is 1 to the 5. So what do you get? You get t to the minus 4 is equal to 1. Let's rewrite this as 1 over t to the 4 is equal to 1. This is equivalent to t to the 4 is equal to 1. And how many solutions do you have for this? 2 solutions. What are they? 1 and minus 1 is equivalent to t is equal to 1 or t is equal to minus 1. So how many critical numbers do I have here? 3. What are they? 1 and minus 1 is where the derivative is 0. And I have an extra one where the derivative does not exist, but the function is defined. Okay, so critical numbers, let's end this. So it's minus 1, 0, 1. Is this clear? Was this clear? Okay, thank you very much, and see you on